Sometimes the base of a power is not just a single number or a single variable. Sometimes the base of a power is a product. For example, the base of this power is A times B. A times B is a product. When the base of a power is a product, we apply the exponent to each of the factors in that product. So we have A to the n times B to the n, applying that exponent of n to A, applying that exponent of n to B. This is the power of a product rule. Let's understand why this rule works by looking at an example of a power of a product. 3n to the fifth is the product 3n raised to the fifth power. My base is the product 3n. And then expanding this, I have 3n times 3n times 3n times 3n times 3n. Looking at this expanded form, I see I have 5 factors of 3. 3 times 3 times 3 times 3 times 3. 3 to the fifth. I also have 5 factors of n times n times n times n times n. So 3 to the fifth times n to the fifth. This is exactly what the power of a product rule tells us. We're applying that exponent of 5 to the 3. We're applying that exponent of 5 to the n. In this case, I could go ahead and calculate that value of 3 to the fifth, but it's not really the point of what we're looking at. 3 to the fifth, so I'm going to have 9 times 3, 81 times 3. So this we could write as 243 n to the fifth. Now we want to compare the case of a base of 3n to this case, 3 times n to the fifth. The power of a product rule only applies to a coefficient if the coefficient is within the parentheses, meaning it's part of the base. Here there's no parentheses, so the coefficient is just 3 times n to the fifth. So 3 times n times n times n times n times n. 3 times n to the fifth can't be simplified any further. It's just 3n to the fifth. There's only one factor of 3. Notice that this rule applies when one or more of the factors is itself a power. So here I have a product as my base, but each of those factors is itself a power. Therefore, when I apply my exponent to each of the factors, I will be using the power rule. So I'll be multiplying the exponents. A to the x, b to the y, all of that raised to the n power is a to the x times n times b to the y times n. This may be a little more clear with an example. So here we have a product where each of those factors is itself a power. That means we're raising x squared to the fifth power and we're raising y to the fourth to the fifth power. So x squared is being raised to the fifth and y to the fourth is being raised to the fifth. Like I said above, that means we're just using the power rule, so we're multiplying our exponents. X squared raised to the fifth is x to the 10th. Y to the fourth raised to the fifth is y to the 20th. That's exactly what we said above. I'm multiplying 2 times 5 for my exponent on x, and I'm multiplying 4 times 5 for my exponent for y. Let's practice. Here we have a product with 3 factors. We have 13 times x to the fourth times y. We're going to apply that exponent of 2 to the 13. We're going to apply the exponent of 2 to y to the fourth. That means y to the fourth squared, y to the 8th. And then applying that exponent of 2 to the y. 13 squared times x to the 8th times y squared. 13 squared is a perfect square that I should have memorized, so I can write the value 169 x to the 8th y to the y squared. Next example, first factor a cubed, second factor b to the 7th, third factor c squared. I'm going to go ahead and apply that exponent of 10 to each of those factors. A cubed to the 10th is a to the 3 times 10, a to the 30th. B to the 7th raised to the 10th power is b to the 7 times 10, b to the 70th. And then c squared raised to the 10th is c to the 2 times 10, c to the 20th power. We are just multiplying our exponents here using that power rule. Which, by the way, you can just think of these factors that aren't themselves powers as having an exponent of 1. So you can still think of yourself as multiplying the exponents. So y to the first times 2 is y squared. 13 to the first times 2 is 13 squared. Same thing here. Really common for students to write c times d to the 30th. Applying that exponent of 6 to d to the 5th, but not c. So we're applying the 6 to the factor of c, c to the 6th. If you want to think of c as having an invisible exponent of 1, you can do that. Think of that as multiplying those exponents. Here is an important piece of information to keep in mind. A negative sign within the parentheses indicates a factor of -1. So here I actually have -1 times a to the x power raised to the n. That means I'm going to have one factor, -1 raised to the n power, times a to the x raised to the n power. We have talked about this before, but what that means is in the case of an even exponent, -1 squared times x to the 3rd squared, which is x to the 6th, I can actually simplify this -1 squared to be +1, and my final simplified expression will be x to the 6th power. Here, I have a coefficient of -1 being raised to the 5th power, an odd power, times x to the 3rd raised to the 5th, x to the 3 times 5, x to the 15th. Now when I'm raising -1 to an odd power, I know that that simplifies to -1. So now I have -1 times x to the 15th, which is just negative x to the 15th. We really want you to write this step and not just go straight to here to get full credit, so that we understand, if you understand, why our final expression has a negative sign in front or not. So this one does not, because -1 squared is +1. This one does have a negative sign because -1 raised to the 5th power is -1.